Merci beaucoup, Marc, and Clément, Xiao Xiao. It's just such an honor to be here at the DVIC inauguration. I've known Clément Duhart for, must be 6 years now. He was a student in my group, a visiting student as a PhD here in Paris, and did some great work with our team, and kept digging into many, many projects. So I was very close to Clément as he was developing and growing. And it's just been so wonderful to see him come back to France, to Paris, and start this institute here, and take a little piece of the Media Lab and create it on French soil, and just watch it grow. It's been so marvelous to see. So it's an honor to be here and give the opening talk at the inauguration. So, as Marc said, we tend to look at sensors. We're living now in the age of the sensors. Sensors are everywhere. We know that now. Back when I talked about it 25 years ago, it was less certain, but it's for sure happened. And what I tend to say is that the sensor data itself isn't what's so interesting. It's the space between the sensors. It's what the sensors say when they drive models and make predictions. And we're very much living in that world. So my group tends to look at putting the sensing out and getting that information, interpreting it, and bringing it back to people in different ways, how people connect to sensors across many scales. So a quick outline. I'll start with a little bit about the Media Lab, just to give you some orientation. My colleagues may also talk a bit about the lab. A little bit about me, how I came to do what I do. And then I'll go into a few very quick arcs of technology, where a project may start in my lab doing something, but it changes and it twists and it turns with innovation and becomes something very different over several years when it goes from project to project. And I've got a few examples of different technologies I'll discuss. So the Media Lab. Magic is used with the Media Lab very often, and I have to admit, it does fit. It is kind of a magical place. It's a place where you really can imagine anything. I mean, there are no boundaries, right? We're not a discipline as such. We're more of a lifestyle. I don't know if I'm allowed to say that, but I think that's really what we are. So you're encouraged to come in and think boldly, think across boundaries, think about things in a different way. Imagine a future. We're about the future. But don't just imagine it and criticize culturally what it could be. Yeah, you do some of that. But bring it down to earth, incarnate it, make it into something that people can experience, build it. We're very much builders, we're very much doers. We like to realize things, not just talk about it, not just simulate it or calculate it, make it so you can get a taste of what this future could be. And we look at many possible futures, not just one. And again, we're very interdisciplinary. That's one of our secrets. We're like a university within a university. We have people that are good at all different kinds of fields. They work together, they collaborate. Our students also are good at several different things, and they work together. Oftentimes, people have different expertises, even in the same faculty or the same group. We like to be in everybody else's business. We're not siloed into a narrow department like you would be in a regular university, or even regular departments at MIT. We try to think very broadly. So we look at how disciplines clash, and at that clash, there's something new and interesting. We love that. So it's an electric atmosphere. If you go there, even when I go on a tour, right, if I accompany a visitor and I go to the different groups, it's mind-blowing because you're getting exposed to all these different aspects, these different views of the future. So electric is the word. And it's not the kind of place where you can close your door and just concentrate on something or relax. There's always an interruption. Students asking about different things from other groups, not just from mine, and I love it. Even though I say I only have 2 minutes, they'll come and I'll spend a half an hour, the best half an hour of my day. But we have visitors from member companies that come, all kinds of interesting people that come through. So it's always a churn of different opinions, different points of view. It's all about interruption, but it's good. And of course, late at night, we do our work. That's when we can maybe close our door. The Media Lab is really a place about convergence. Again, convergence of disciplines. And we used to always draw our organization as intersecting circles. So on the left are some older kind of, I don't call them org charts, but descriptions of what the Media Lab would be. So it started really as classic convergence, publishing, computers, and broadcasts, basically all the media industries converging onto a computational platform. In the 80s, when we started it, that was not a given. People didn't realize that that would necessarily be the way of the future. It was. The lab predicted it. Our founder, Nicholas Negroponte, basically articulated the word convergence. Then we looked at different kinds of convergence as we went. So bits, atoms, and projects. Stuff of technology, software, and people. So how that comes together. And now we're more or less body-brain technology. It's really human extension. How humans connect to this world beyond us and how we extend through doing that. So I'd say that probably describes a lot of what goes on at the lab. Not everything. And our colleague Neri Oxman years ago put together what she called this Krebs cycle, the way that the bacteria basically recycles its material into energy and then back into growing. She's interpreted here as a cycle going from art and design into science and engineering. There's a relationship between both of them. At the Media Lab, we kind of live in all of these quadrants all the time, and we move. Projects can kind of move across. We like people that can cross these boundaries. So that's why I was drawn to the Media Lab. All of my roads kind of met there. As a kid, I was building sensors, pretty much everything, as long as I can remember. I was always building some kind of a sensor system, so this goes way back for me. But then there was another pull in my life. I love music. Those of you who know me know that I'm totally passionate about music. It's more than an avocation. It's a big part of my life. So how do you bring these two together? Science went out. I did my PhD in high energy physics at MIT, working in the group of Sam Ting. Just after he won the Nobel Prize, I joined the group. And I went to work at CERN. This is actually the DAISY E plus E minus collider in Hamburg. But I did my thesis actually in France. So this is where I did it. It's the intersecting storage rings at CERN. I don't know if any of you remember that. Some of you are old enough to remember. It was the highest energy collider, proton-proton collider, in its day when I was working there. Not for very long, the new accelerators came up. But it was in France. The Swiss border is probably about 300 meters on the other side of the ring. So I did my thesis in France. A wonderful time. And French culture had a huge influence on me because I ate it up. I was a kid coming out of Boston, basically, and I was here. Every time I could have a chance, I'd climb up the Jura. It was just always wonderful. Get lost in the Alps. I'd drive through the Pays in my little sports car. It was great. I just loved it. And of course, it wasn't just the wonderful scenery, the wonderful cuisine, the food, the culture. It was also my friends at CERN. So I worked with European colleagues and French colleagues who really were very influential. And Professor François Vinci from Paris University, Cité, is here at the moment. He mentored me on my first talk back in 1979 at CERN. So I owe a debt to this country, and I'm so glad to be back. There are other, of course, music kept its hold. And ever since I can remember, I was always collecting unusual music. I still do. And when I come to France, I find the weird record stores right away and get the strange music. I'm just drawn to it. But I loved electronic music as a child. So I would absorb this stuff and listen to all this and wonder how they made it. And I tried to make it myself. And eventually I realized that I wanted to build a synthesizer like this if I wanted to do this. So I started building a synthesizer as an undergraduate. This is in 1975. That's how I learned electronics, basically. And then it got much bigger. This is at the MIT Museum after I built it quite a bit more. There's audio on this, actually. Do you guys have it? Is there? Yeah, there's sound. You can turn it up a little bit. Good, thank you. It's making this music by itself. So you program it with patching. It's a connectionist architecture by default. I'm an engineer. I'm an artist when I use this. And I just put together this program through the chords that basically just generates this music, and it goes on forever. This is a piece, again, that came out of the MIT Museum, streamed around the world when I ran it. It's continued. This is my basement now at home. Just some months ago, I have a studio there. It's probably the biggest homemade synthesizer in the world if you look at it, but I've been adding more to it. It's growing. Like Stephen King's Rose Red, it just keeps growing. And I still do pieces. This is a piece I did actually for an arts event at the Media Lab just a few months ago. So again, I take pedals apart and I turn them into part of the system so I can patch them. I modify all of my equipment. I build new equipment and design it. Some people work on their car. I work on synthesizers. So it just sits there and sits in this musical space and just dreams it. It's basically dreaming this music. Anyway, more of that on the web if you like it. I've got all the pieces posted there, and I keep doing work. But back to the group. We look at how people connect to sensors, and we look at it across many scales. So we work on wearables, we work on things in building scale, and landscapes, and now more and more space. We have projects that are actually going into space. So at the Media Lab, we can work really at all of these scales, even within one group. And I'll give you some examples of how a project may start as a wearable, then become something that we launch into space. This is the snapshot of the group. We all have group pictures that change over the years. But this is my group over probably the last 5 years. We have 10 to 20 students in my group, typically a lot of visitors from all over the world that come in addition to MIT students. And you see this character kind of in the front here. Where's Kilroy? He's always here, right? That's Clément, the founder of the Institute. And it was so great to have him with us. He really integrated with the group, integrated with the Media Lab, and was very much there for us. So wearables. With the Institute, probably, if you look at any institute that worked with wearables, we're probably the best known. Our students were living this world of wearing a computer back in the mid-90s. You see Steve Mann and Thad Starner here, two of the most famous, but many of the students were doing this. And they weren't just doing it for fun, they were doing it because they believed in it. They really would live that life. So we all wanted to do wearable projects. This is the first one that I made. It was a sensor node for the shoe of a dancer. So when the dancer moves, I had 16 sensors in each shoe, wireless connection from the shoe to a computer that would interpret the data and make music. So the music comes from the dancer's dance. Not so unusual now. Even the sensor suite is not so unusual now, but in 1997, I would go through a list of the sensors on the shoe and people would laugh. They thought it was crazy. But look at this watch. This is, the same kind of a thing. We're living in that world now. So we did many, many other wearable projects, but we tend to take it to extremes. This is a project that my student Artem did together with Sham, one of Hiroshi's alumni at Stanford, and Cindy Kao in another group, but Artem is the architect of the actual robot. We thought about what happens if wearables move, if they can be dynamic, if they can move around the body. It's a different world. Most wearables, like a watch, just stay. Have the wearable go to where it can do its job best. So we invented the rovables, and that's a little micro-robot that can navigate on clothing. So here they go to where they may be best for motion capture, for example. And you're driving a puppet. So it's capturing his motion. Here, it's something like a watch. So it goes to where you want a display for your wrist. Now you need more real estate in your display, and they find each other. This is some notification or something poked you. This is Cindy's work. She gets a call. The microphone goes from where it's aesthetic to where it should be to receive the call.
Incoming call. Leonardo DiCaprio. Hey, Cindy Cow.
And then I pushed Artem to think about something maybe more practical. What about robots not crawling just on clothing, but crawling on the body? So he made a series of different robots. On the left, they're just flexible robotics that can kind of creep and crawl. On the right, it's a pneumatic robot that can actually navigate on the skin, crawl across, and carry a payload of instruments that can observe the skin. It can locate certain areas. It can navigate across and even deliver therapy and do different kinds of sensing. So you think of an era when you can't get a doctor, you can't get a gantry robot, these little micro robots can come out and do something. They even started to be able to stand without the pneumatic tube. The pumps get better and better. So this is something that gets ever closer to being practical. We made the cover of the IEEE Biomedical Journal with this one. It's a radical idea. It's an idea, though, that is coming. And of course, we can put things into space, as I mentioned. The first step to space is a zero-gravity flight. I've been on several of them. This is me achieving karmic levitation. Zero gravity helps a lot if you want to levitate. And we just put a paper out. It's coming out actually in a few months, describing many of our projects that start as a project in pervasive, ubiquitous computing, Internet of Things, and move into a space project. So we have several conveyors. I'm just going to give a couple of examples. The robots you saw crawling on clothing, we thought would be great to crawl on spacecraft. So you have a problem in a spacecraft, you can't easily go outside to check it out because you have to go in an EVA, you have to have a suit, you have to be able to get over there. Just have it crawl, make a robot crawl and make the diagnosis. So we made a swarm of these robots, different kinds of sensing and diagnostics to see what would be wrong with the vehicle. So imaging and acoustic diagnosis, so on and so forth. And we tested them on zero gravity flights so they can traverse different kinds of terrain that you'd expect maybe on a spacecraft, different kinds of surfaces. It's actually going to be going up to the space station, I believe, soon. And we're actually launching even sooner to the moon. So at the end of this year, we have a small amount of payload we can run as part of a rover project. And we have made a little rover that will crawl on top of the big rover to diagnose the heat transfer capability of the heat shield, to image it and diagnose it. This will be the world's smallest planetary rover. And it has a thermal sensor, it can navigate, it will roll out and look at how the heat is transferring off the shield. And again, it has a little house. Once it lands, it'll open, and the rover will come out and do its thing. We also have sensors to wearables that look at people, but try to, instead of just looking at motion and so on like we used to do before, like more or less like our watch does, it's measuring our motion in different ways, look at our internal state. So sense things like cognitive load, sense focus, sense attention. So we took a set of glasses. My students are very good now at making glasses after going on a manufacturing course in Shenzhen that we offered and working with some of our member companies who make glasses. We put a set of sensors in there to try to look at the internal state. So we measure the temperature at different parts around the head because the temperature distribution around your skull between your nose and your temples changes according to cognitive load. We look at head motion, that can indicate focus. We look at eye dynamics as well, and other things. We put that together to try to get some idea of how focused people are. And David Ramsey even has lights at the edges that glow in more and more intensely. So he can look at intention. How close are people focused on the task? If they see a green light or if they notice it, they'll tap their watch in his tests. So the glasses are testing focus and distraction. We also have added air quality sensors to them. You can get now sensors to measure several parameters of the air you breathe that are very small. We put them above the bridge of the nose so we can get the air that you breathe. And the new version has air analysis. So we're doing an experiment with several universities around the globe in Freiburg in Switzerland, Netherlands, and in Singapore, giving people a set of these glasses and an app that goes with them to see how their well-being state, their cognitive state varies with air quality. We can measure that. We can test them to see how they perform. This is another technical arc. I call it Sensei Media. It's putting sensor networks onto material. Because we now have sensing, we have computation. At some point, that marries with material. Hiroshi will give you a different view of this kind of a thing. It's intriguing to think about this. We've been talking about this since the early 2000s. And we've built many versions of it where you have computation, sensing, the sensors talk locally through the media, and you can build it into all different kinds of structures, including tape. This is the sensor tape. It's sensors as utility. You can roll it out like tape and cut it and tape it onto something, and it can measure all kinds of parameters. Ermity now, my student doing the work, is looking at putting them into fabric, where you have networks of processors and sensors that are on flex, so it's stretchable. And he intends to put it down on clothing, basically your fabric, and you've got this dense sensor processor soup that can measure lots of things and use it for all kinds of applications. It's a new kind of smart material. He's already done some work making a vest that has flexible connects between the sensors. It has only one processor, but it's got sensing distributed throughout the vest to look at biophysical parameters. And it's very robust. He can put it in the washing machine and put it on to wash, and even while it's being washed, it still makes its measurements. So we're going to be pushing this even further now. But we're thinking about textiles as sensors, and just if you weave a textile in certain ways, it can look at pressure, stretch, different kinds of parameters. So you can start making clothing that's sensate. We have a knitting machine. We just knit this stuff in my lab now. Hiroshi also is making things like this you'll hear about in a minute. This is a keyboard that Ermity made that I could actually play. So it's a capacitive touch sensing keyboard. But this one can change color because it's electrochromic. So you put some current in, you can change physically the way it looks. But then for his next act, he made a keyboard that measured many, many different things and came off the knitting machine directly as well. So this is our latest knitted keyboard, and it measures capacitive proximity, so it measures where your hands are above, measures pressure when you push down. That's not so unusual, keyboards do that. But it measures stretch. I've never seen a keyboard that can measure stretch, but fabric stretch, we can measure that. That's an input parameter. And you can play it virtuosically. We had Jordan Rudess, the famous keyboard player from progressive rock and Dream Theater, very well known, classically trained, visit my group just a couple of months ago to try it out. He's all excited about this idea. And we can knit textiles that encircle the body. Ermity has done this with dense measurements of pressure, temperature. You can look at blood flow in different ways, even done differential blood pressure with this. He's made a sock, which you can wear as a shoe, that measures pressure in very, very fine grain across the shoe and wirelessly offloads it outside. Here he's walking on his shoe. You can see the result. He's made carpets. You can knit a whole carpet. The carpet is a sensate structure. So as you walk on it, you can measure the pressure and you can locate people. So you can give it to, let's say, a dancer, and now the dancer does a performance and the music comes out of the dancer's gesture. And of course, having artists in the group is great because one of my students, Dawn, did the music and Ermity did the carpet. Great collaboration. This is Ermity running it into a machine learning, right? So you can classify different kinds of gestures. You can use it as a virtual reality input device, so we can walk through Minecraft in this case and visit the virtual media lab. But then he can also train it on yoga poses. He likes to do yoga, so now it just from the weight distribution he's trained it, it can tell him, if I'm analyzing the feet, how well he's doing. And this is kind of one of the extreme places it's gone. My student Juliana was fascinated with the idea of putting piezoelectric fiber into the cloth that lines spacecraft, the protective cloth. It's called beta cloth, very tough. It protects and thermally manages spacecraft. What if you could put little piezoelectric fibers in there? Then the beta cloth can measure impacts, micrometeorite impacts, very small impacts. We don't know how often they come and when they come. We know they do come. But now if your spacecraft gets hit, we know where, we know how much, we can know the integrated impact, know when it happened. So she has made a space cloth like this. We flew a passive sample on the space station last year. This year we're flying an active sample. That's the active sample that's there now. It was launched just last summer and it's on the space station now actually sending data back. And this is preliminary data. Juliana's still analyzing it, but it looks like we're seeing impacts that are coming. First time people have ever seen micrometeorite impacts in real time. And they tend to come in clusters. There's sprays of stuff, basically, that hit it. Very, very tiny particles, but they're there, and we see them. We won awards for this. She won the top prize in NASA TEPRIS contest, for example. And she likes to measure cosmic dust. She's a physicist at heart. So she wants to go back now to research, and this is one of her ideas, using the same kind of a detector. This is the last part of the talk. I love music, I love concerts. If I had time, I would go to Le Triton, my favorite jazz club in Paris. I've saw Magma there many times. It's a great place to go. You have so many wonderful venues for music here. And it's great that we can go back to see them again. This is the Roundhouse in London. I gave a colloquium for Imperial College, electrical engineering, a few years ago. I asked them to give it the night before one of my favorite bands played at the Roundhouse, so I could go. And it's great. What's special about a concert? Being with people, not just seeing the music, but the people around you. During pandemic, this was me going to a festival. This is actually a French band, Ghost Rhythms, great band from Paris. And I have a great sound system. I have my pet rabbit. It was wonderful. I have a great TV. But it's not the same as being in a crowd enjoying a concert. So yeah, what's special about being somewhere? This is a big question. I mean, we had Zoom, right? And we still use it. It was awful at the beginning of the pandemic when we took this picture, but we have it. But we're going to go much better than that. What is it going to be? So my group has been thinking for a long time now, what's the essence of being somewhere? How can you expand experience by connecting to sensors that are everywhere? We've written articles about this. This was the cover of Scientific American some years back. And we've done many projects. This is the Doppel Lab. I want to show a little bit of this. It's a CAD version of our building, what people call digital twin now. But through animations, we're basically showing the sensor data. So you can go through the virtual building and see how the real building is behaving. So you see the temperature, humidity by the fog, by the color. You get close enough, you see a value. You see people walking around the building. If they have RFID, you see things that signify motion. And you can hear what happens in the building. So you're hearing, if you're near a microphone in the real world, if you're near a microphone in the virtual world that corresponds to the real world location, you can start hearing it. So these are people. We're going to an area where there are people. You can hear them. You cannot understand anything they say. They are speaking English. And we distort the sound, we obscure it so you cannot understand them, but you see that they're laughing, you see that they're happy, you get the gist of a space. It's a ghostly presence. So then we figured, okay, let's push it a little further. Let's go out into a beautiful outdoor location. This is a cranberry farm that was restored to a wetland. Used to be owned by is owned by one of our former faculty. But she decided to turn it into a natural preserve. We put sensors there to measure that process. We developed our own sensor that measures lots of things that are relevant to the environment. Since it's a wetland, we put many sensors in the soil too. And we made hundreds of them. And we put them in all kinds of locations there. This is a transect, for example. We put them in the water, right? We put them into the ground. It is a wetland. And we can get lots of data. So this is temperature over a year at different parts of the wetland. This is hydration. We built them to measure that. We work with hydrology scientists. You can see the response to different rainfall events at different parts of the property and how it responds at different depths. So we've got lots of data. But what excites us is trying to bring this into the virtual world again, but do it in a very aesthetic way. So bring an analog or an analogy to the marsh in a virtual environment you can experience and enjoy. So music comes from the sensors, visuals come from it. It's a very immersive experience. We call it Doppelmarsch. And here you see the bubble goes up when a sensor updates. The weather changes with the real weather. That's no big deal now. But you can hear by the timbre and the pitch, the temperature and the humidity and the conditions of the sensor location. And it's spatialized. You can look at different visual filters if you want, but you can also move through this area, and the music will change. As you move to different parts where different sensors are that have different values, you hear it differently. If I have time, I would run it. It takes time to set it up. It still runs now. It sounds very different because it's a lot colder now. This is a different musical mapping. We built frameworks for composers to do different pieces on the data from the marsh. And this is a composer, this faculty at MIT that collaborated with us. And I think data is the canvas for future artists. Many, many pieces will happen from this large-scale data, and I think it's still a very exciting time. This field is still growing, and I think this is going to be a whole set of future artworks that can be very inspirational to come from it. We have audio everywhere, too, microphones. And of course, you can do lots of things with the microphones, including identify species of wildlife. And this is where our French collaborators came in. Félix Michaud, who worked with him on, built a classifier to listen to different bird species back when this was not easy to do. So 2018, 2019, this is before eBird and became common. And Clément Duhart, for part of his thesis, built a machine classifier to in real time recognize different bird species that were there, and different ways of interactively labeling the data as if it was a game. And of course, you look at a day, you see different species coming out at different times, you know, crickets and frogs and insects at night, birds during the day, and then different species of birds. So we have a lot of data. This is from Felix. You can see migration patterns in different birds, different years. We have data that goes back years. Different cicada broods coming out different years as well. So the data is rich, and with machine learning, we can start building structure from it. This is the last thing. This is a project that Gershon Dublon ran. Gershon was fundamental in the Doppelmarsch work, and this is a big part of his thesis. He's here somewhere in the audience. And we thought, remotely looking into an environment with virtual means we've done. What if you're really there? How can we bring this up into your consciousness? So we built what we called Here There. It's a system where we can locate you with GPS. We have all the microphones and sensors that make audio in the environment and have it come up into your hearing as if it's natural, because we can track your head direction and we can have the audio come as if it's part of your hearing. But it's audio that's coming from other places. And it's bone conduction. It doesn't cover your ears. It expands your hearing. So this is Dan Gager, collaborator of ours from Bose.
Life.
A very different experience for him. He's designed every great headphone Bose has made. For him, it's different. And this is a system where I didn't want to take it off. Most VR, AR gear I have on, I'm happy when it goes away. This expanded me. I did not want to take it off. And I think that's a future, right? We want to get to a point where we're enhanced by this, not diminished. So looking to the future of this, I'm fascinated with this idea of scalable presence. I have something, my doorbell manifests on my watch, even here in Paris, or I can be immersed looking at a screen or even have wear a display. So there's a space between that that's navigable in, I think, a continuous fashion. How can you navigate that? The other thing is trying to map sensory data from things that don't have an analog, machine learning intent or something like that, onto different kinds of inputs to people. How do you do that? So you develop new senses for people that don't correspond to physical normal phenomena. Another thing I call identity casting. If you look at, for instance, at a swarm of insects in this case, or a swarm of birds, or even a swarm of drones, can you be the leader? Can you be the swarm? Can you be a follower and move fluidly between that? With the technologies that we play with now, I think you can. Another area of interest. And then my student Don Haddad is working with David Newman's students to try to think of hybrid mixed reality ops for space, where things are different delays, different distances. You have AIs and people all combining with data. How do you do this in a fluid fashion? I think it's an open question, and we're ready to try to resolve it. So, in conclusion, this world comes fast. I think there's plenty to do before we become fully immersed. Are there ways that this world of data can come into our perception to give us a fuller, richer experience of the real world instead of being distracted by it? I think it's pretty critical. What are the interfaces to do this, and how do they scale? And finally, where does self-stop and other begin? When you start blending into this network, identity becomes actually part of the mix. So thank you very much. Merci beaucoup.